All right. Thanks, everyone, for joining us here on the Inside a Docker Cryptojacking Exploit webinar with ThreatStack. My name's Mike Broberg. I'll be hosting you good folks today. And with me is Ethan Hansen. He's a security analyst here in ThreatStack's SOC. Ethan, hello.
Hello, Mike. Good to be here.
Awesome. Well, thanks for coming along for the ride. Looking forward to walking through this kind of Docker crypto mining thing we're going to talk about soon. But I guess first, I will just kind of kick things off by talking just briefly about containers. Everyone here, I'm sure, knows what they are, but I think an interesting benefit of containers is that, they provide a certain level of isolation for your applications that makes them easy to kind of, manage the lifecycle of your apps. So, building on Linux primitives like namespaces and C groups and, sharing, hardware resources more directly on the host is kind of one way that they really, enable that ease of use and kind of ephemeral nature of containers where they're moving around, being born and reborn constantly across your infrastructure. But like any new tool, people can misuse them. And just kind of emphasizing here that containers really are that kind of lifecycle deployment tool when you're frequently deploying new versions of your application. And while they do provide a certain level of isolation, they're not specifically a security tool. It's not that full kind of isolation you would get when you're kind of running your own virtual machine with its own kernel and own virtualized hardware stack. So just kind of trying to drive that point home that containers can, if used properly, contribute to a defense in depth strategy, but they're not a security tool in and of themselves.
One sec. Yeah, they're good for separating out your services, do some microservices type stuff. But if somebody gets on one of your Docker containers and starts eating up your RAM, eating up your CPU, it's eating up the RAM and CPU of the host, and it can do some denial of service type attacks there.
Yeah, that's what we call here a denial of resources or denial of wallet attack, because it'll end up costing you kind of money and perhaps downtime as well. And so, just moving on real quickly, like we just kind of touched on denial of resources attack. If you're kind of running a lot of Docker containers and someone wants to take down your servers by spinning up a ton of containers, but there are other considerations too. Just because you're running things in containers doesn't mean that security considerations kind of magically disappear. If you're using an orchestration tool like Kubernetes, you have to secure that control plane. If you log into your cloud provider, the same way you need to be careful about root access to your virtual hosts. Same thing with Kubernetes logging in to the web dashboard or using the command line tools. If someone's able to gain access to your master node infrastructure on Kubernetes, they just could own all your servers that Kubernetes is managing. And then kind of further up the stack, if you're using managed container services, it's just that kind of shared responsibility, trust that you have to put in that provider. All right. So moving on to our example, the cryptojacking attempt on a Docker container that Ethan's going to get into. I just kind of want to say, he works in our SOC. The folks in our security operations center are looking at events and alerts on our customers' infrastructure and the signals that the kind of threat stack monitoring agent is sending up to the platform. And threat stack, just to kind of set some context, does this at the kind of system call level, so it's able to kind of see what's going on in the Linux kernel and get folks kind of a real high fidelity signal of what their infrastructure is actually doing. It comes down to either you are reading a bunch of logs or you're, kind of triaging alerts and using a platform like ThreatStack, that kind of stuff. That's what Ethan is going to kind of talk to today.
So as Mike put it so eloquently, the ThreatStack platform is really powerful and you can use it in a couple of ways. You can use it to say monitor your environment and get emails or webhooks or using our API, you can get notified every time an alert comes into your environment and have your security team or your DevOps team or your engineers kind of manage it yourselves. Or you can leverage the threat stack SOC and let us look at your environment, and we'll go through and we'll triage alerts and we'll run them down and we'll give you all the context necessary to make a decision. It's more than just seeing an alert title. It's seeing the alert title. It's seeing everything associated with that alert. We really dive deep on every single alert. So just give a quick overview. Step one really is the attacker needs to identify a website or websites that are vulnerable to remote code injection. Remote code injection is pretty much when the attacker is able to execute code through a website, through like a console or the URL, any sort of way. They're able to inject their own custom code, and then that filters down to the operating system, or in this case, the container. So once the attacker is able to do that, we move on to the next step. However the attacker does it, whether it's via the URL or whether via a live console or anything like that, the attacker is able to take their code or their script or their command and execute in the application layer, and then that is then translated to the container, and then the container is then spun up, and then the code is then executed inside the container. Now, around step 3 is where we at ThreatStack in our platform will start seeing events. Not necessarily alerts, depending on how your system is configured, but we will start seeing events which will let us, as security analysts, kind of rebuild the attack as it happens. So this is an example of an actual event from this attack where what we saw was Python-I, which means the attacker was able to spawn an interactive Python shell and then was able to type Python code directly into this shell. They didn't run a script. They didn't run anything like that, so we didn't see any arguments. But this is our first indication of, okay, something is kind of happening.
Imagine that for the majority of cases, if you ever have a container and you're seeing that someone's launching a shell in that container, that's kind of your first big red flag.
Yeah. In this case, it's Python interactive shell. We do have alerts on, services running shell and stuff like that. But,
right.
This is your first indication something's going a little weird. So step 4 that happened live, we saw in the customer environment, is that a cryptomining executable was downloaded to the local file system. And I kind of want to stress here that the next series of events happened all within about a second of each other. Most likely somebody pasted in an entire script, hit enter, and everything started happening. So what we see here is the attacker running a wget, naming it CNRig, and going to get this Linux executable, downloading it to the local file system. This is kind of the first step here, the first thing the script did. CNRig in this case is the crypto miner they downloaded. It's a relatively high performance CPU miner, and the real distinguishing feature here is that it auto updates. It's got also compatibility with all distributions, which means you can download it, run it, and forget it. Which is probably why it was used in this particular attack to be like, oh, I'll just download this, it'll run, and I won't have to worry about it. It'll just continue to mine me.
Yeah, this seems like it's like really one of those kind of like low effort, kind of cast a wide net attacks that is common with a lot of hackers.
Yeah, no, very common with the, hit as many targets as I possibly can and what comes what may. There's nothing inherently wrong with crypto mining if you do it on your own systems. Just want to stress that there. It's there's people who make legitimate businesses out of crypto mining. Just do it on your own systems.
Build your own crypto rig.
Yeah, build your own crypto rig. Don't abuse other people's. Then we start getting into the real red flag area here. Modifying permissions. In this case, we saw chmod plus X on CNRig, and what that means is chmod basically is changing the permissions on the file and saying, please give me the owner executable permissions. which means they don't have to do anything special to run this file. They can just basically run it as it is. It'll execute and run. And this is something that, in general, you should not be seeing on containers. Containers are meant to be non-interactive. They're meant for microservices. They're meant to run a system-level type stuff. If you start seeing chmod plus X in your containers, unless you are literally sitting in front of a console, that's a sign that something starts going a little weird. And again, depending on your environment, you can craft an alert to say, okay, if it's a container and I start seeing chmod plus X, shoot me an alert.
Which someone like you would see.
Yeah, and someone like me would see. And then we would dig into it, and we would send you a nice email saying, did you really mean to do this?
Yeah.
The next step is executing the crypto mining application. ./CNRig, which in Linux parlance is execute. It's basically the same thing as double-clicking on exe in Windows. And in this case, you'll see there's a lot of flags on this. You've got his donate level, the type of currency he's using, his email. We saw his email, and the pool he was using in the port. Just to give some background on that, pool is, it's basically a collection of servers, usually sitting behind a load balancer that, it goes out and it's like, okay, server A, server B. So in this case, it's just basically a collection of servers. And this is where we got our alert. The CNRig actually running is when the threat stack SOC first saw the alerts. As soon as that executable ran, we got an alert. We got this alert right here: potential exploit activity, process activity from the temp directory. This is part of the base rule set. It looks for any sort of process activity from the temp directory, whether it's a start, a connect, and accept, because malware has a tendency to run out of the temp directory. If somebody's trying to escalate privileges, the temp directory is usually a pretty good place to start, because usually you should not configure it this way. Anybody can download and execute stuff out of the temp directory. So we saw this, and we saw CNRig, and some research later was like, oh, wow, that's a crypto miner, and we should probably keep digging into this. And all the slides you saw earlier, was our investigation. Kind of we pieced together this after the fact. We did some digging, and we found that the last step in this was CNRig attempted to make outbound network connections. So it attempted to go from the container through the host and through the public internet. And these are the 3 connections it attempted to make. You made 2 over that port we saw earlier as part of the pool, and made 1 connection over 443, which is commonly associated with HTTPS, to what looked like a content delivery network. Now I want to say attempted here because these connection attempts did not repeat. Normally with processes that make network connections, you see multiple network connections over and over again, and it keeps doing it over and over again.
And it's really important, too, that you were able to find the context of, like, when those connections opened, around that, like, who opened them, what were they, what commands preceded the opening of those connections. Because if you were just looking at it from the network layer, like, you wouldn't have that.
It's great, the fact that we can recreate this entire attack sequence. We can trace back the processes. We can say with pretty, definitively, this spawned this, which did this. Whereas, yeah, you're right. If we were just looking at the network layer, we wouldn't be able to see that.
It looked like any other, SSL connection or whatever.
And we do this with every single alert. We go in, we find parent processes, we find connections, we find associated processes. What did that person do before? What did that person do after? And having that visibility into the application, into the host, is amazing. So that's really, 7 steps of a crypto miner attack. This actually happened. We caught it. We researched it. We reached out to the customer. And that's kind of what the SOC does. We see things, we research them, reach out to the customer, and 99.9% of the time, it might be nothing. But then this shows that 0.1%, that 1% of the time that, we see and we catch legitimate, actionable events.
And you're someone who likes reading logs, too.
Yeah, so I really am, coming from the the system administrator background, I'm very used to trolling through logs manually. And if I had to troll through a log manually to find this, like I've done stuff like that. I've picked out the needle in the haystack, and being able to use a platform that kind of picks out the first needle for you and allows you to very quickly find associated events is great.
Right on.
I really like that. So let's talk about misconfigurations and misuses of Docker.
Yeah, so I'll just kind of recap like a couple things. You kind of addressed in your talk, and maybe there are a couple other things that we didn't explicitly address. But inbound HTTP requests to containers, to me, just as someone who like has played with Docker locally on their machine and kind of has an idea of microservices infrastructure, like if you're using containers as immutable infrastructure, right? Like being aware of which ones are able to talk to the network is really important, because either you have like something like Nginx that's load balancing or might be acting as a web server, or you have like application layer stuff that you probably don't want to be network addressable. So that's just a big, I think, first takeaway for me, is like knowing which of your containers can talk to the wider internet and not, and having a real justification for why.
And it's like having a container doesn't solve the general issue of like having what a DMZ is supposed to be, or you shouldn't have your application layer talk to the internet directly. You should have a very specific pipeline, and stuff should live in the DMZ and shouldn't be the public internet. Docker microservices are great, but you still have to have that mindset of, okay, lowest possible attack surface, only expose what needs to be exposed, which leads us into SSH and Docker.
Right. Yeah. So I mean, that was we did explicitly call this one out, which was basically anytime you have a container that has a shell launched inside of it, that's usually a big warning sign, unless, like Ethan said, you're literally sitting at the console doing it yourself.
Yeah. The threat stack has a set of Docker rules that follow the CIS guidelines, and one of them is SSH server running in the container. Per the CIS guidelines, you should not be doing this. You should SSH into the host and then jump from the host to the Docker container. That's the way you're supposed to be doing it. If you're running microservices, like, you shouldn't really be SSHing in the box. Like, if you're running a SQL server, would you be SSHing in the SQL server all the time? Unless you're running maintenance or something like that? No, you have it automated.
Right.
Like, that's the entire point of like that microservices kind of model.
You have a DBA who's doing it like right there in person.
Yeah, which I mean, I guess SQL Server is a bad example here, because like DBA's got to administer it, but you get what I'm saying.
Yeah, I get what you're saying. So running Docker as root. So I guess we didn't really talk about this, but running privileged containers is just something to really be aware of, because I'm not a Docker expert, but I know enough that the way Docker kind of remaps user IDs from outside of the container and then inside the container, if you have privileged containers running in your infrastructure, then you need to know which ones have rootly powers across your host.
It's like, it's all about your business model, because sometimes you can't avoid privileged containers.
Right.
But it's really knowing what's privileged containers, reducing your attack surface, using service roles, like making sure that, okay, let me define a specific role that has a specific set of permissions, and I know that this role is running Docker. Like, just a general kind of just reduce your attack surface as much as possible, and just be aware of what's running as, a privileged container in your environment. Yeah,
and in this one we covered it's just having a container with the underlying file system as writable, right? And that was a big kind of thing that let the potential crypto mining event happen in the first place, right? In the scenario we ran through.
So without going into how Docker maps things in terms of the Linux file system, basically, as it says in the last point, you're not supposed to make the underlying file system that's like on the host writable. You should explicitly define a container volume, explicitly define a directory, and don't just let things get written to temp or anywhere, because then you run into issues of people downloading executables and making them executable and running them. So that's a CIS guideline that we have. That's a severity 1 that says you start your Docker container with the root file system writable. And again, this is within your business model, but you should be very careful of, do I really need the root file system to be writable? I'm running a microservice that's automated. Like, do I need this to be writable by anybody, basically?
Yeah, and like you said, it's a matter of the business model. If you have a legitimate business reason for having to do that, then by all means, like, know that that's like security risk that you're assuming, and you'll be fine. You'll be able to put kind of checks in other places.
Exactly. Like, if in terms of threat stack, you're working with the security engineer on your account, and you say, my business model says I need my root file system writable. We know that. We can, work with you to say, okay, let's come up with a custom rule that says only this specific directory should only be writable, and then you can use FIM rules or stuff like that to say, okay, so I'm aware of this. I'm going to work to make controls around this.
Yeah. And I think the last big one on here is, you limit not set. And I know that kind of touches on the kind of denial of resources kind of idea we chatted about earlier. I don't know if you have anything more you want to add in terms of kind of setting kind of resource limits on containers, how much they can consume from a specific host, something like that.
Yeah, I mean, in general, your container shouldn't be allowed to use 100% of your host resources. Again, this goes back to your business model. It's like, okay, if you're just running a simple web server, probably doesn't need to, and you're running, some host with 256 gigs of RAM and like 16 cores. Like, does your web server really need to use 256 gigs of RAM?
Yeah.
And that goes back to the denial of resources. Somebody could, get onto your Docker container and spike your CPU and spike your memory, and then that's actually spiking your host memory and your host CPU, and then it leads you into a whole another world of hurt, basically.
Yeah, right on. Well, I think that kind of recaps everything there. And kind of before moving on to the Q&A, I'd just like to reinforce, I hope Ethan has kind of given you a good idea of what the Threat Stack Cloud SecOps program is, what it does. We have many other security analysts like Ethan looking at people's threat stack alerts, digging into events in their threat stack accounts, and raising their hands and letting folks know, like, hey, we investigated this. We think this is like a highly legitimate area for you to prioritize your security response in, and kind of go from there.